Righto, Year 12, let's have a look at question 19C. Now, I did do this in class, and I'm going to do it both ways with the t formula and using the r sine theta. So 19C is cos x plus root 3 sine x equals 2. Now, in the HSC, they will tell you to rewrite this expression, this side of the equation, as r sine or cos x plus alpha or beta or some other Greek symbol. So the first thing you do is, you realise there's a 1 in front of that cos. And then you let the numbers in front of the trig ratios be the short sides of a right angled triangle, 1 and root 3. You then use Pythagoras to work out the hypotenuse. So you go, the root 3 squared is 3, 1 squared is 1, 3 plus 1 is 4, the square root of 4 is 2. And what you want to do is you want to get this 1 and this root 3 in terms of a trig ratio. But you can't do that unless you write them as a fraction. So I'm going to multiply by 2, and I'm going to go, well, that's 1 over 2 cos x plus root 3 over 2 sine x. Remember, this is just the left-hand side of this equation. It's just an expression. I'm rewriting that left-hand side as r sine. Now, I want that half. Because this is a plus, I look at my formula sheet and I see which one has a plus. And it's the sine theta. Right? Now, they'll usually tell you which one to pick and lead you in the right direction, because if you go the wrong direction, it gets extremely hard at the end. So I'm looking for the sine theta plus phi formula. So I need to express this half as sine alpha. So in this little triangle over here, I'm going to put my alpha there. And therefore, sine alpha equals a half, and cos alpha equals root 3 on 2. So my expression becomes 2 sine alpha cos x plus cos alpha sine x. Now that can be written as 2 sine alpha plus x, but because it doesn't matter which way I add, I can write that as 2 sine x plus alpha. Now if I put back my equation, if I then say, well, that equals 2, that equals 2, that equals 2, that equals 2, I can now solve it. The first thing I do is I divide both sides by 2, and I get sine x plus alpha equals 1. I think back to my curve, my sine curve, and the two spots where it equals 1, well, there's only one of them, and it's here at pi on 2, because that's pi, it's 2 pi. If I continued the graph, there would be another one here at 2 pi plus pi on 2, which is 5 pi on 2. But I don't need to do that because I'm only limited to 2 pi, and even if I were to go an acute angle back there, I still wouldn't reach that pi on 2, that 5 pi on 2. So I only have to take this one answer, but it's good to know that x plus alpha equals inverse sine of 1, which is pi on 2. So x plus alpha equals pi on 2. Well, we know what alpha is. If we go over here, this is our right angle triangle. Alpha equals that angle in there, which is pi on 6. This angle in here is pi on 3. You could go inverse sine of a half, and it would tell you that it's 30, and then you'd have to convert it. So it's pi on 6. So down here now, I go x equals pi on 2 minus pi on 6, which equals 3 pi on 6 minus 1 pi on 6, which is 2 pi on 6, which simplifies to pi on 3, which is the answer. Now, the alternate way to do this is with t formula. This is a method I stuffed up. Let's take it again using t formula. So what was our equation again? Cos x plus root 3 sine x equals 2. Now, looking at that section of your formula sheet, you can see the t formulas. Now, the t formulas are just a way of writing all the trig formulas in form of all the trig ratios in terms of t. You get one variable and you solve it. It gets a little bit complicated because you can get a quadratic. So I'm going to make this substitution. I'm going to let t equal tan theta on 2. Now, they give you the formulas, and I've shown you where they come from, but we can go over that another time. They now say cos theta in terms of t is 1 minus t squared on 1 plus t squared plus root 3, and sine theta is 2t on 1 plus t squared, which equals 2. So, first thing, let's multiply both sides by 1 plus t squared. And that'll give me 1 minus, get your ruler out, 1 minus t squared plus root 3, or 2 root 3 t equals 2 outside of 1 plus t squared. 1 minus t squared plus 2 root 3 t equals 2 plus 2t squared. Tied it all up and take everything over to the right-hand side, and I get 0 equals 3t squared, because that 1t squared, that negative t squared becomes over here, becomes plus 2 root 3t, no, not plus, minus, and if I minus that 1, I get plus 1. So I look at this and I go, oh, this is pretty ugly. I'm going to have to use a quadratic formula. So t equals minus b, so minus 2 root 3, plus or minus the square root of b squared. Well, 2 squared is 4 and root 3 squared is 3, and 4 times 3 is 12. I'd probably write that out, but it's up to you. Minus 4 times 3 times 1 over 2 times 3, which gives me 2 root 3 plus or minus 0 over 6. 2 root 3 plus or minus, the 0, 12. That's going to make it easier, which gives me root 3 on 3. So now I know that t equals root 3 on 3. I go back and look at my substitution. What do I let tan theta on 2? Therefore, tan theta on 2 equals root 3 on 3. Now that's a bit difficult. Why don't I simplify, or multiply by root 3, multiply by root 3. That'll give me 3 on 3 root 3, which cancels, which gives me 1 on root 3. And I'm lucky because I know from my right angled triangle that 1, 2, root 3 pi on 3 pi on 6. I know that triangle. So therefore, tan theta on 2 equals 1 on root 3. Theta on 2 equals the inverse tan of 1 on root 3, which equals pi on 3. But were there any others? Well, let's check. Here's tan, and there's my first one, my pi on 3. And I think I've messed this up. Yes, it's not pi on 3, it's pi on 6. So there is my answer, pi on 6. And the other one here is pi plus pi on 6. Pi, so I've got to get pi plus pi on 6. So, all right, so I get pi on 6 and 6 pi plus pi on 6. So that's theta on 2. So theta equals pi on 6, or 7 pi on 6. Now multiply by the 2, and I get theta equals 2 pi on 6, or 14 pi on 6. So theta equals pi on 3, or 7 pi on 3. But remember, our solutions must be between 0 and 2 pi. And this is bigger than 2 pi. So therefore, our only answer is pi on 3. So the T formula is just a method for eliminating these things, and then using your algebra to pop out an answer. It does look more complicated, but after a while you get used to it. The r sine theta, I much prefer it. I find it much more logical. It turns those numbers into a trig ratio, and then you use your double angle formulas to help you get there, which are all on the formula sheet. Anyway, good luck. Have a go at the other ones.